All right, guys, the number of positive integers less than 50 having exactly two distinct factors other than 1 in itself is. All right, I just want you all to look at this. The way they confuse, they twist the words, they mince the words, they play with the words. You want the number which have exactly two distinct factors other than 1 itself. Basically, we want numbers that have exactly four factors, right? Okay, two distinct factors, one and themselves. So we want numbers which have exactly four factors. Now, guys, we know this concept that for any number n, if it is prime factorized as a raised to p, b raised to q, c raised to r, so on and so forth, the number of factors is given by p plus 1 into q plus 1 into r plus 1, so on and so forth. So basically, we want numbers, okay, of the form a raised to p, b raised to q, c raised to r, so on and so forth, such that the product p plus 1 into q plus 1 into r plus 1 should be equal to 4, right? This product should be equal to 4. Now, obviously, if you write 4, guys, we have very limited ways of factorizing 4 as a product of 1 or 2 or 3 numbers, right? So if you're writing 4, one way would be you can write this as probably 1 into 4. So p plus 1 or q plus 1, some of them, like one of them will be 1, the other would be 4. This is one way out. The only other way is you write this 4 as 2 into 2, right? If you use multiple terms like 1 into 1 into 4, it's the same thing. I mean, p plus 1 becomes 1 and q plus 1 becomes 1. So p becomes 0 and q becomes 0. The only other way out is r plus 1 will be 4. So it's again the first case that we discussed, right? So we have very limited cases here, okay? To get the product 4 here, there are now only two ways out, okay? P plus 1 will be 1, q plus 1 will be 4, or p plus 1 will be 2 and q plus 1 will be 2. So C ka term to nahi hoga. We won't have any term of C here and any term onwards. Okay. So from the first case, P plus 1 is 1 giving you P is 0. Q plus 1 is 4 giving you Q is equal to 3. So the number should be of the form A raised to 0 and B raised to 3. This is the first way out, right? And guys, the second possibility we discussed is P plus 1 is 2 and Q plus 1 is also 2. That gives you P is equal to 1 and Q also equal to 1, right? For that, we have only one way of writing the number, A raised to 1 and B raised to 1. So the first form of the number should be A raised to 0 into B cube. The second form is A raised to 1 into B raised to 1. Okay, so now we'll discuss these two cases in detail. Matter of factly, you can also ignore A raised to 0 here. You can simply focus on the form of the number as B cube or A cube directly. And second form of the number should be A raised to 1 into B raised to 1. Now you can cross check the number of factors here will be 3 plus 1, 4 as required. And here also number of factors will be 1 plus 1, 2 and 1 plus 1, 2. 2 into 2 will again give you 4. Right? All right. So let's talk about the first case, guys. The number of the form A cube. We want the number of the form A cube and it should be less than 50. All right. So when we look at this particular type, we will observe that the number should be 2 cube. That's 8, less than 50, obviously. The number can be 3 cube as well. 3 cube is 27, obviously, less than 50. And the next prime number is 5. So 5 cube will be 125. No, that's not possible. We have to take numbers less than 50, right? So of the form A cube, we have only two possible numbers, 8 and 27. So now let's talk about the second case, guys. What if the number is of the form A raised to 1 into B raised to 1? Okay, let's take the smallest possible value of A now. Let A be equal to 2. Now we want the number to be less than 50, right, guys? So A into B should be less than 50, or in the first case, when I take A is equal to 2, 2 into B should be less than or equal to 50. Okay, less than 50 here compulsorily. So A 2 into B should be strictly less than 50. Thereby, P should be less than 25. So P can be any prime number less than 25. And obviously, B cannot be equal to 2, right? So distinct prime numbers we need here, right? So a prime number more than 2, but less than 25, B can take these many values. B can be 3, B can be 5, B can be 7, 11, 13, 17, 19, and 23. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8. Exactly 8 values, right? This is the first case. Now, second case, guys, let's take A is equal to 3. If you take A is equal to 3, then 3 into b should be less than 50. That should give you b is less than 50 by 3. 50 by 3 is what? 16.66 recurring. Okay, so b has to be any prime number less than 16.66 and more than 3, because it cannot be equal to 3 also. So b can be now 5, b can be 7, b can be 11, and b can be 13 as well. So there are 4 such values, right? So the third case will be when a is 5. For that, 5 into b should be less than 50, or b should be less than 50 upon 5, which is 10. Now b has to be any prime number which is greater than 5 but less than 10. So there's only one way out. B can only be equal to 7, right? And there is no need to check the further cases, guys, because the case will now only repeat. When you take a as 7, then you'll get b to be less than equal to 50 by 7. So we'll again get these values. B can be 3, then can be 5, and so on and so forth, right? So we do not check these values again. They'll be repeated now. So from here, we get only one value. From here, you have 4. From here, you have 8. And from here, you have exactly two values, two possible values for the number, right? The final answer will be 8 or 4 or 2 or 1. The total comes out to be 15. So how many positive integers less than 50 satisfy this condition? The answer is 15, the correct answer to your question.